Hey, welcome everyone to the 5th episode of MicroPython series where I'll make sure that you all get comfortable in using MicroPython on ESP32 board for any of your projects. This episode is going to be very interesting and useful because by end of this episode, we'll be making our own home automation project in which we'll be controlling up to 4 AC appliances via web page by using the socket programming in MicroPython on our ESP32 board. And in the meantime, we'll be learning about what is TCP and UDP protocol and what are the differences between them. We'll also be learning about one website on which you can actually visualize the HTML document, and we'll be also saying a couple of tags in the HTML document. And before moving on to the final project, we'll also be learning about the sample code in which we'll be controlling one single built-in LED using the socket programming on MicroPython. So that being said, let's start with the 5th episode. This video is sponsored by LTM, which is a PCB designer based software company. Now if I tell you one very interesting feature of this software, then here in LTM Designer you can design rigid flex PCB. Now what is that? So till now you must have designed the PCB which is like rigid, like solid PCBs that we are not able to bend. But here in LTM you can design a PCB in which some of the parts are rigid solid and some of the parts are flexible which can bend, and the PCB can we can bend it in a two-fold manner just like the modern day smartphone, right? So this is a really very interesting, useful and unique feature of the software. Well, you can also try out this and many other unique and interesting features of this designer software by just clicking on the link mentioned in the description. Yes, by clicking on the link you'll get access to the free trial version of this software. So go ahead, try out the free trial version of LTM Designer software. Now if you're watching this series for the very first time, I'll suggest you to watch out all the previous episodes of the series whose link you can find in the description of this video. And that being said, let's jump onto a computer and start with the 5th episode. So here I'll open this Thorny ID on my system and I'll paste this code here. Now don't worry, I'll be explaining each and every line in this code so that you can modify this code for making your own home automation project. Okay, so let's start with the explanation of this code. So first of all, we included the necessary modules required for this particular script, starting from the machine module, which is used for utilizing the GPIO pins of the ESP32 board. Straight after that, here we have used the uSocket module, which is the new module which we have used in this particular series. So this is used for the socket programming of our MicroPython for sending and receiving data via internet socket. Okay, so I have used the uSocket. Now to check whether this uSocket module is built inside your MicroPython version or not, you just need to type here as help into the bracket, just type modules inside this inverted comma and press enter. And if I press enter, as you can see, these are the modules which are built inside my MicroPython version, and here is the uSocket module already available, so I can use it straight away. So here I used as import uSocket as socket. It's just because by writing this command, this whole code will also support inside the actual Python version. Okay, so Python uses the socket module while the MicroPython uses the uSocket module, which is like the trimmed out version of the socket module. Okay, so I use this as socket just to make both the codes look exactly the same. Okay, after that I imported the time module just for the delays, and in the end I used the network module for the Wi-Fi connections. Okay, so after the module, here is the first variable declared called as timeout, which will be responsible for timeout of Wi-Fi connection. That will look inside the code later on. After that, we have declared the Wi-Fi object, which will be responsible for all the Wi-Fi related tasks like connecting to the router and getting the local IP address, stuff like that. And here we have declared our Wi-Fi network as a station mode. We can also use it in access point mode that we have discussed in the previous episode. And after that, what we are doing is we are restarting the Wi-Fi. So we are turning off the Wi-Fi, like the built-in Wi-Fi, and after 500 milliseconds we're turning it on just to make sure that Wi-Fi works fine. So we are basically resetting the Wi-Fi at initial stage. After that, we are connecting our Wi-Fi or rather ESP32 board to the particular router whose SSID is this and whose password is this. So in case you have open network router, you can delete this password, keep it as it is, and it will get connected to it. Okay, in my case it is password protected, so I'll use this password. After that, here we have used this if and while conditions just to make sure that our code don't get stuck inside the infinite while loop. If we have provided wrong credentials, if the router is not available, it will jump out of this after 5 seconds. Okay, that is a 5-second timeout I have provided. Straight after that, if it is connected to the Wi-Fi network, it will just print connected. It will also print the local IP address assigned to the ESP32 board, which is must because using that local IP address will be able to access the built-in web page of the ESP32. Okay, after that, here we have declared the HTML document. Okay, so here is that HTML HTML document. Now for those who haven't used the HTML, rather haven't seen the HTML document before this particular video, it may seems confusing. So what I'll do, I'll suggest you one website on which we can actually visualize what is this particular HTML document all about and how things will work. Okay, so I'll simply copy this particular document. I'll go to one website called as w3schools.com. Now if you are familiar with this thing, it's pretty cool, but if you're not, then this is an amazing website for learning new languages. And not only that, they have built-in interpreter or built-in, we can say, terminal windows where you can write your code and test it in real time here inside the same platform. So they have also what you can say, this particular thing for the HTML document. So you just need to paste your HTML document here, and if you click on the run button, you'll able to see the what is the HTML document actually stands for. Okay, so these much line of code will print this much thing inside your web browser. Okay, so we have used the heading tag just to display this ESP32 web server as a heading. Okay, so it is under the heading 2 tag, so its font will be a little bit bigger, and below that we have used the LED, which is also a heading, but it is of heading it is of tag h3, that means the heading 3, which will be a smaller, or what you can say, a font size. Okay, straight after that we have used the button tag, and inside that tag we have provided the name as LED, the value as on, and type as submit. Okay, now what does this mean? This means that it is a button. Okay, it is a clickable button as it is written as submit. So it is a clickable button, and as soon as someone click on this particular on button, the value on will be stored inside the variable LED. Okay, similarly, if anyone clicks on this button, the value off will be stored inside the variable called as LED. Okay, so that's basically what is happening inside this button tag. Okay, so this is a very basic HTML document. Okay, so there will be an LED and there will be on and off button, and we'll be using this HTML document or a web page to control the built-in LED of our ESP32 board. Okay, so that's the simple thing, and you can change the things here to visualize what like how each tag is working. So if I change it to true and click on the run button, as you can see, the true appears here. Okay, so this is a very great website to visualize these things. Okay, so I'll keep it as on. Okay, so yeah, this is that HTML document stored inside the HTML variable. We will be using this variable or this HTML document later on in this code. Okay, so after this HTML document, what we are doing is we are declaring some pin as output. So here we are using one single pin as pin number 2 on which the built-in LED is connected, and we are declaring it as an output. After declaring it as an output, we are storing the value 0 by default, so it will be turning the LED off as soon as the code starts running. Okay, now comes the time to declare or initialize the socket. Okay, so here we have to initialize the socket, and here we need to provide some compulsory commands to make it work. Okay, and these are those commands. So first of all, we need to define what kind of socket we are using. Okay, so here we have written as AF_INET, which stands for internet socket. Now sockets are a very different type. So here we are using the internet socket, but we do have Bluetooth sockets, we do have IR sockets, if I'm not wrong, and there are several different kind of sockets available. Now I'm confused like whether these kind of sockets are available in MicroPython or not. I have seen these different kinds of sockets in Python, but still there's confusion whether all are available in MicroPython or not. Okay, but yeah, there are different kind of sockets, that is clear. Okay, and after that we have defined here as sock_stream, which stands for the TCP protocol. So we have these two kinds of protocol here for data transfer. One is the TCP, the second is the UDP protocol. So what are they and what are the basic difference of them? So TCP protocol is kind of a reliable protocol in which whenever we send the data, we can be sure whether the data is sent or not. We get the feedback, we get the response. Okay, while in the UDP it's not the case. Once the data is sent, we can't guarantee whether the data will be received on the other side or not. Okay, so that's the one of the difference you can say. A second thing is, like, one question arises, why to use the UDP protocol? Like, what are its benefits whether we are not at all getting the response? Now the benefit is UDP provides a very fast data transfer rate, so it's like almost a real-time data transfer, but that's not the case in TCP. Okay, now again one question arises that what are the applications of both the protocols? Can you give some examples? Well, yes, I can give the example. So you need to use the TCP protocol whenever you want the reliable communication. For example, in the messaging a task, maybe like a text message or internet message. Okay, so when you want to send some actual message to the receiver, you want the message to be delivered. Okay, so for that reliable connection is needed, and for that you need to use the TCP protocol. But in some scenarios where the speed is the issue, where you want to send tons of data at a time. For example, in the gaming servers, for example, in the video streaming, in those kind of situations where real time is the thing, where data transfer rate should be high, okay? But if you miss some of the packets, it's not an issue. Like if you're streaming the video and if there is a missing of a data of some of the pixels, the video won't be damaged, or there won't be any miscommunication if there are some pixels lost, okay? So in those scenarios you can go for UDP protocol. So there's the very basic difference I have given here. For more details you can Google it, of course, okay? So yeah, here we are using the TCP protocol for the reliable communication, okay? Straight after that, here we have to provide the host and the port number, okay? Now what is this? So here we have to provide a host, and here we have to provide the IP address, a particular IP address. Now why to provide a particular IP address? Now if you want to if I want our server to get connected to one single IP address only, that means only one IP address or one device can communicate to this particular thing, we need to provide the specific IP address here, okay? And in case if you want the multiple IP address, or rather you don't want to restrict it to any IP addresses, you can keep it blank as I kept here, and this will allow all the devices to communicate with this particular ESP server, you can see, okay? There is no restriction. And here we have provided the port as 80 because we'll be communicating via our web browser that works on the HTTP protocol, and the port number for the HTTP is 80. That's the by default port, okay? That's why we have written 80. And after that we need to write this command to assign that host and port. After that we have written here as listen 5, and it will handle the maximum 5 clients at a time. So what happened, it will only handle 5 clients at a time, and if the 6th client want to enter or want to connect with it, it will be in the queue, and if any case one of the client gets exited from this communication, the 6th will be entered. So this is how this thing will work, okay? That was all about the socket initialization and socket configurations, we can say. Straight after that, let's jump on to the while loop, like the main loop of the code, and this is where the game starts, or we can say the actual things happens, okay? So here what we are doing is we are using one command called as s.accept, which will be waiting for the new connections to get connected with our web server or socket server on our ESP32 board, okay? So as soon as the new device get connected, we are storing 2 data. One is the connection socket, so we are creating a different socket for the different client, and after that we are storing the address of that particular client, okay? And after storing the address, we are printing that address in the second line. Straight after that, we are also storing the data, whatever data coming from the client side, inside one variable called as request, and here we have provided the buffer size as 1024, and this data will be stored in bytes format, okay? So that's the thing, you need to make sure that here. And after that, we are printing whatever data received from the client side as it is inside the terminal, okay? So that's a basic thing, getting the connection, getting the data, printing on it, okay? So that is what happening up till this. After that, what we are doing is we are converting that bytes formatted data into the string format by using the str function. Now why we are doing this, that's a very important question to be asked. So straight after this particular line, what we are doing is we're using one function called as .find. Now this is the function used in string, like string.find, okay? So what it will do, it will find this particular word inside the whole string, and this will only work when we have a string formatted data, and that's why we have converted this into string format just in the above line, okay? So what we are finding, that is there any word or something that is called as LED is equal to on, or if there is something in the string called as LED is equal to off. So we are finding a particular word in this whole string that we are receiving, okay? So now to make it more clear, what I'll do is I'll keep the explanation up till now here. I'll run the code and I'll let you know how, like what kind of data we are receiving from the client, and then we'll be able to understand it much better, okay? So what I'll do, I'll save this particular file inside the MicroPython device with the name main.py, and this should be clear with you, like why we have written main.py, okay? So we have saved it. I'll click on the run button, okay? So it should get connected with my Wi-Fi router. Okay, it's starting for the connection. Okay, it's got connected, got the local IP address. I'll copy this local IP address. I'll paste that local IP address in the new tab of my Safari web browser. Press enter, and as you can see, we got the web page as expected, okay? And here, as you can see, we got the data as got the connection from this local IP address, which is the IP address of my Mac system, and this is what the data is being sent to by my Mac system. Okay, and as soon as I click on the on button, let's just observe what data we are getting. First of all, let's just observe this address. So as you can see, as soon as I clicked on the on button, the address changed to $LED is equal to on, and same thing happened when I click on the off button. The address changes to $LED is equal to off. Okay, so that's the thing we are getting. So let's just click on the on button and let's observe what data we are getting. So as you can see, this is the data that we are receiving from the client side, and as you can see, here is that particular word which is $LED is equal to on. Okay, so we are finding this word inside the whole string, and what this command will do, it will not only find that thing, it will also return the position where this word is actually in the whole string. Okay, for example, let us start counting from this till 1 2 3 4 5 6. So at the 6th position we are getting that particular word. Okay, so this will return 6 and it will store inside the LED on variable. Okay, so it will do two tasks. If it is there, it will find that word, and if it is there, it will return the command or the position of that particular word. Okay, so that the thing is happening here. Similarly, if we are getting this word inside the string, it will return its address. Okay, and the address will be the same because this will be getting inside this particular 6th position only. I hope we are getting understanding this particular thing. Okay, so if the press on button, will be getting this thing on the 6th position, so we're turning on the LED. If the user press the off button, we'll be getting this thing on the 6th position, so we need to turn off the LED. Got it? I hope you are clear with this. Okay, so after that, what we are doing is we are again sending that same HTML document to that connected client. Okay, so every time the user press any button, we are sending the same web page. So you noticed here, whenever I click on any button, we are getting the same web page here. It's just because we are sending the same HTML place again and again to that particular user, and after doing that, we are closing the socket. Okay, so once the data is sent and received, we are closing the connection. We are no more connected with each other until and unless the new data is transferred. Okay, so that's the thing. So that's the basic socket server code. It written inside the MicroPython device, and it's actually working. Like you can see, I'm able to turn on and off the LED, like the built-in LED on my ESP32 board using the simple web page, and it's in real time. I'm able to do that. It's just because it is a local internet network connection, so it's like no latency at all. So yeah, that was the code about the socket programming, and I hope you got to understand each and every line of code, and tried my best to explain it in a simple way possible. Okay, but we are still remaining with one more thing, that is to make the actual home automation project, and for that I already written one script. I'll let you know. So yeah, here is the code for the 4 appliance control like home automation project code, and here is the changed HTML document. And if I copy this HTML document and paste it inside the W3 Schools website and press the run button, as you can see, now I have 4 different LED variables, and like each variable has the 2 different buttons, like on button and off button. So here what I changed here is I changed the name, like the heading of course, and inside that I also changed the variable name, like the name of the button. So we'll be getting the LED 1 on and off, LED 2 on and off, and stuff like that. Okay, and here as you can see, I defined the 4 different LEDs on like 4 different GPIOs on which I have connected the relays, and in the end inside this while loop, I'm checking off the different words like LED 1 on, LED 2 off, LED 3 off, and LED 4. Like I'm checking for all the different words, and according to the data received, I'm turning on and off that particular LED by using that particular dot value function. So that's a simple line of code to control the 4 AC appliances. And for talking about the hardware side, that here are all the components I use for this particular project, and I connected them all according to this connection diagram. Now to make the project more compact and sturdy, I designed my own custom PCB for this project and gave its order to our favorite JLC PCB. So you can order your own custom designed PCBs from JLC PCB by just uploading the Gerber file of the PCB project, selecting the color masking if you want it, and just pay for your order. If you select the fastest delivery option, you may get the PCBs delivered at your doorstep within a week. So do try ordering your own custom designed PCBs from the JLC PCB to make your project looks neat and more compact. So after getting the PCBs, I showed all the components on it, and the final project something like this. Neat and very, very handy. So that was all about the hardware part of the project. So after that, I uploaded this script onto my ESP32 board, and after that I connected the ESP32 board with my PCB project, and I also connected the appliances with the PCB project. And now let's just see this project in action. So as you can see, I'm able to control all the 4 appliances using the web page, and this is all happening using the socket programming done in MicroPython, which is running on the ESP32 board. And we can control the appliances using the smartphone as well. So yeah, that was the amazing project that we made using MicroPython. I hope you liked it, I hope you enjoyed it, I hope you got to learn something new from it. And if it is so, never forget to click the like button if you get some values out of this video. Also, let me know in the comment like what more things you want to learn in MicroPython, and our team will try to make the video for that as well. And that being said, I'm just ending this video here, and now just wait for my next one to explore, learn, share with me, techiesms.